Happy Monday, 4th graders! I hope everyone had an awesome weekend. I hope we all made it safely through those storms that we got early this morning. Let's see. Okay, let's get started. We are on week 4, day 1. Oh, and I started without my utensils. What's that one? That one. Let's see. Okay. Alright, now that I got my pen. We are week 4, day 1, instructional book, pages 294 through 295, practice book 297 through 298, and then we're on day 7 of our countdown. We are still in line plots. Today we are talking about subtracting with line plots. If you remember, Friday we ended our week with adding with line plots. We're doing the same thing except without addition. We're doing subtraction now. So it's going to be relatively the same concept. So stick with me and let's get to it. Starting at the top, there are many kinds of dragonflies that are different in length. A scientist measured the lengths of different kinds of dragonflies and made a line plot to show the measurements. What is the difference between the lengths of the longest dragonfly and the shortest dragonfly? So we know that we're using subtraction because we have our subtraction word in there, the difference. And what we're looking for is the difference between the lengths of the longest dragonfly and the shortest dragonfly. So let's take a look at our line plot. Get in a little bit closer. Alright, so let's look at the fractions below. These are the lengths of the dragonflies in inches. We have, let's look at our denominators. We have an 8, 4, 2, and that looks like it's it. And so in order to do anything with this information, we need to change our fractions so they all have the same denominator, because we can't subtract fractions that don't have or that have different denominators. So I'm going to go to my smallest unit here, and out of eighth, a fourth, and a half, an eighth is my smallest unit. And so I'm going to change this one, this one, this one, this one, this one, and this one into a fraction with a denominator of 8. We can do this a couple different ways. The easiest way you can do this is you can just count the line plot by eighths. So this is 3 and 1/8. Then we have 3 and 3/8 right here. So this must be the same as 3 and 2/8. 3 and 2/8 is equivalent to 3 1/4. Then we have 3/8, and then we have 5/8 over here. So that means this must be 4. 3 and 4/8. See what I'm doing? 1, 2, 3, 4, 5. So this must be 6/8. 3, and I'm just going to write it down here so we can see it. Then we have 7, and then of course 8/8 is another whole, so that's 4. So we have 4 and 1/8. Then we have 4 and 1/4, and then 4 and 3/8. So this must be 1, 2, 3. 4 and 2/8. There's 3, and then we have 5, so this must be 4 and 4/8. We have 4 and 5/8, and then 4 and 7/8 over here, so this must be 4 and 6/8. Another way we could have done that is we could have taken our fractions that did not have an 8 as a denominator, 1/4, a half, and 3/4, and we could find an equivalent fraction by multiplying the numerator and the denominator by the same number in order to get 8 as our new denominator. So what times 4 equals 8? 2. And whenever we're finding equivalent fractions, when we multiply or divide, we have to do the same to the denominator. The same thing we did to the denominator, we must do to the numerator. Now, this is not the case in regular fraction multiplication, if you remember right. Let's do this real quick. 2 times 1 is 2. 2/8, that's what we said. And then we're going to multiply this. We want the denominator of 8. So what times 2 equals 8? 4. 4 times 2 is 8. 4 times 1 is 4. And then in order to get an 8 over here, we have to multiply by 2 again. 2 times 4 is 8. 2 times 3 is 6. 6/8. Real quick, when we're doing normal fraction multiplication, that's when you're working a problem that's actually having you multiply, you do not multiply the denominator. You only ever multiply the numerator. So if I had a fraction like this, it would be 3 times 5 is 15, and the denominator would stay the same. Just to clarify. Anywho, back to the problem at hand. Finding the lengths or the difference of the longest dragonfly and the shortest dragonfly. So they gave you a model here. They said that this top bar is equivalent to 4 7/8, which is the longest dragonfly. And then down here, this part is representing the length of the shortest dragonfly, 3 1/4. The difference in lengths is, this is what we do not know. This is what we do not know. Now, going back to this real quick, how do they know that that's the shortest length of the butterfly? Or not butterfly, dragonfly. Well, they can go up here and they say, okay, I know these ones are going to be my longest, so I need to go all the way over here to the smallest unit that has measurements in it. And that would be 3 1/4. The common mistake is people going all the way over here and saying it's 3. When it's not. We don't have any dragonflies that are 3 inches long, but we do have 3 dragonflies that are 3 1/4 inch long. And then over here we have our longest dragonfly, which is 4 7/8 inches long. They said you can use a number line to solve subtraction problems with the line plots. So all they did was they took the units off of here and they turned it into a regular number line. And then they subtracted the way we subtracted before when we were working with fractions on the number line. They started at the longest. This was our longest dragonfly. We wanted to know the difference between the longest and the shortest, and we just counted back. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. So that was 13 spaces. Well, how much is each of these spaces worth? Well, remember when we changed our fractions over, we changed them to an eighth. So each of these notches is worth an eighth. So I can just multiply. 13 times 1/8 would be 13/8. And I can go through and I can divide that out so I have a mixed number. 8 goes into 13 one time. 8 times 1 is 8. We subtract and we get 1 5/8. Let's break it down. The length of the longest dragonfly was 4 7/8. The length of the shortest dragonfly was 3 1/4. That's just getting the information from my line plot. Number 14 says write an expression that can be used to find the difference between the two lengths. Well, without using the number line, we would just use our standard algorithm for subtraction. And we would have 4 7/8 minus 3 1/4. If we look at the model it on the previous page, it's asking us to explain how you could use the number line with arrows to find the difference between the two lengths. Well, we knew the number line was divided into what? Eighths. the number line was divided by eighths. So each arrow, we said, so each arrow represented subtracting by what? By an eighth. What was our unit of measurement? An inch, an eighth inch. Let's get that unit of measurement in there. So we started at 4 7/8 and then counted back to 3 1/4, finding 13 spaces was the difference. Then we multiplied, and we'll just write this out because I'm running out of room. Then we did 13 times 1/8, and we got 13 eighths. And then we changed that into a mixed number, which was, I can't remember. That's right, 1 5/8. Number 16 says, describe another way to subtract the two lengths by first writing the numbers with the same denominator. So what they're asking you here is if we didn't have the number line, if we weren't able to use those notches and count back and then just figure it out, how would we have solved it? Well, going back up to our expression that we wrote, number 14, we said 4 7/8 minus 3 1/4. But we know we can't subtract that. Why? Because they have different denominators. And so we will change the denominators to an eighth. And we do this by saying, oh, well, we already did it when we did it over here. 3 1/4 is the same as 3 2/8. So, right? Yeah. A brain fart for a second. So we know that our longest dragonfly was 4 7/8, and we're going to change that 3 1/4 to 3 2/8. And then we'll just subtract. We take our whole numbers, 4 minus 3 is 1, and then we take our fractions. 7 minus 2 is 5/8. And there's our answer. Let's try it out. Number 17. What length are the greatest number of dragonflies? What is the difference between this length and the shortest length? Not exactly. The greatest number of dragonflies are 4.5 inches long. We want to go back over here, and we got to look at our line plot. They're asking what length are the greatest numbers. So which measurement were most dragonflies measuring at? Well, 3 2/8 only had 3 dragonflies. We only had 3 here, 2 here, 3 here, 1 here. But then we skyrocket. So this one will be, this is where most of our dragonflies fall when it comes to how long they are. We have 1, 2, 3, 4, and 5. So we have 5 dragonflies that are at 4.5 inches long. So 4.5 inches long is our average. What is the difference between this length and the shortest length? Well, the smallest dragonflies were 3 1/4 or 3 2/8. So we want to find the difference, so we're going to take 4 1/2 and we're going to subtract it by 3 1/4. So we took the measurement of the most common measurement of dragonflies, meaning the dragonflies that there were more dragonflies at 4 1/2 inches long than any other measurement. And then we took the shortest length, which was 3 1/4, and we're just going to find the difference. But we have a problem here. Our denominators are not the same. So what we're going to have to do is we're going to have to change the denominators. And we can do this by taking, we know that we can take 4. We can make 2 into 4, right? So we're going to take that 4, we're going to take that half out. We're going to bring it down here for a second. We want to multiply it by a number in order to get 4 as our denominator. So what times 2 equals 4? And whatever we do to the bottom, we must do to the top. So 2 times 2 is 4. 2 times 1 is 2. So now we have 4 2/4 minus 3 1/4. And we get the answer. We subtract our whole numbers. 4 minus 3 is 1. Then we subtract our numerators. 2 minus 1 is 1. And our denominator stays the same. Let's do some practice. Alrighty, guys. So we are in the practice book, page 297, subtracting line plots. Let's look at our example. The monthly rainfall in inches for one city is shown in the line plot. What is the difference? There's our subtraction word right there. What is the difference in inches of rain between the month with the greatest amount of rain and the month with the least amount of rain? So we're looking for the most rain dropped and the least rain dropped. Let's look at our line plot. We have eighths, fourths, and halves. And so we need to change those so all of our denominators match. Quickest way to do that is to just count by eighths, because that's our smallest unit. If that's 1/8, this must be 2/8. If that is 3/8, this must be 4/8. That's 5, so this must be 6. There we go. That's 1, so that must be 2. 2 and 2/8, 3/8, 4/8, 5/8, and 6/8. Okay. I always like to do that to start. Draw little lines because I kind of got sideways on that for a second. Alright, write a subtraction expression. So we took the month with the most, which was over here, and the month with the least, which was over here. Remember, this would count because there was no month had this amount of rainfall. Only this month did. And we set up our subtraction. We write the numbers in fourths so that they match. So all we did here was we went backwards. If we wanted to get a fraction out of 3, all we need to do is find the division problem that would give us 3, because fraction is only just division. So if I wanted an answer to be 3, it would be 12/4. 5/4, we just changed this mixed number into an improper fraction. So we did 4 times 1 is 4. Add that 1, we got 5/4. Then they had us find the difference, where we just subtracted across, and we got our answer. They started with an improper, and they had to change it to a mixed number. Alright, number 1. Which questions below can be answered using the line plot in the example above? Circle all that apply. So let's look at A. In 3 months, it rained the same amount. What is the difference between the amount and the month when it rained the most? So the first thing we need to do is look up look back into our line plot and find out if there were 3 months that rained the same amount. Now remember, each of these X's is a month. Okay? So if each of these X's were a month, we need an amount of rainfall that had 3 months that had the same. So it wouldn't be 1 1/4 because it only had 1 month. It wouldn't be 1 1/2 because it only had 1 month. It wouldn't be 1 5/8 because it only has 2. We want 3, so we're going to go all the way to 2 1/8. And so we can solve that because that information is true. So we're going to circle it. B, what was the total amount of rainfall for the year? Well, in order to see if our line plot would answer that, we need to know how many months are in a year. There are 12 months in a year, and so I need to make sure that I have 12 months represented up here in my line plot. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, I can answer that because I have 12 months, which is the same as a year. C, in how many months did it rain more than 2 inches? So in order for us to be able to use our line plot to answer that question, I need months that it did rain more than 2 inches. So if our line plot cut off here, like if this part didn't exist, I wouldn't be able to answer that question because there were no months that rained more than 2 inches. But it's not. It's asking how many months did it rain more than 2 inches, and our line plot goes all the way to 3. So we could totally answer that question. And then D, how much rainfall occurred in January? Well, there's a problem here. I don't know what month these actually are. I just know that they are a month. This could be June, this could be August, October, it could be any of the months. I don't know. It's not labeled that way. So we can't answer that question. 2. Look at the choices you circled in problem 1. Which can be solved using subtraction? What is the solution? So let's go back up to here. So let's look at our 3 questions that we knew we could answer. And we want to find one of the questions that would have to use subtraction. So in C it says, in how many months did it rain more than 2 inches? Well, we're not going to use subtraction there because all we have to do is count. 1, 2, 3, 4, 5, 6, 7. There were 7 months. I didn't have to add. Well, I did technically have to add because I had to count, but I didn't have to subtract. B, what was the total amount of rainfall for the year? Well, total amount, that's asking me to add, so that's not going to work. A says, in 3 months it rained the same amount. What is the difference between that amount and the amount in the month when it rained the most? So they want us to go back and look at the 3 months that were all the same, and the difference, subtract it from the month when it rained the most, which would be over here. So we have 3. So we're going to take 2 1/8 and we're going to subtract it from our month that had the most. So the most it rained was 3 inches. The average, or the most common rainfall, was 2 1/8. And in order to solve this, I need to make a denominator of 8 over here. So 8 times 3 is 24, and that would give me 8. Beautiful. And we're going to subtract it, and since this is an improper fraction, I'm going to go ahead and turn this into an improper fraction. 8 times 2 is 16. That would be 17 eighths. Ouch. Let's see. I don't know why I put that O there now, because that would have been 3 if I would have turned that, put a 1 under it, and I wanted to get 8. That'd be 8 There we go. Yeah, no, I don't know what that 0 was there for. Y'all, it's Monday. My brain is funny. 24 minus 17 is 7, and our denominator doesn't change. So we have 7/8. Number 3. Marine biologists caught fish for research. They measured the sea bass they caught and recorded the length in the line plot below. So we have length in inches, and each one of these X's is worth 1 fish. The question says, what is the difference, there's our subtraction word, in the length between the longest and shortest sea bass that the biologist found? So we want the longest, so we're going to go all the way over here. Is it going to be 14? No, because there were no fishes that were worth 14 inches. We got to go to the first one, or the last one that has a fish in it, which would be 13 7/8. And we know we're subtracting, because we saw that, the difference. Now we need to find the shortest. The shortest is going to be all the way over here. Is it this? Is it 12? No, because 12 does not have a fish over it. We need to go to the part, or the measurement that actually had a fish on it, which would be 2 1/4. When we have 13 7/8 and 2 1/4, we need to change our denominators so that they're the same. So I'm going to pull that 1/4 out. 1/4 is equivalent to, if this is 1/8 and this is 3/8, that'd be 2/4. And so this is the same as 13 7/8 minus 12 and 2/8. And then we can just subtract from there. We take our whole numbers first, then we subtract our numerators, and we get 1 5/8. Number 4. Sea bass that are caught and that have a length less than 13 inches must be thrown back into the ocean. How many more inches does the shortest fish need to grow before it can be taken out of the ocean? So all of our fish must be 13 inches. Or they have to be thrown back. If you are heavy into fishing, you know this. If you catch a fish and it doesn't weigh a certain amount, or if it's not quite long enough, it's not grown up, you have to throw it back into the water. Anyhow, so we want any of these fishes that are not exactly 13 inches, they got to go back to the sea. So we have, let's see, the smallest, right? How many more inches does the shortest fish need to grow? Okay, so the smallest fish would be over here. So we want to find the difference, so we're subtracting 12 1/4. If I wanted to subtract these, I need to get a fraction over here. These need to look a little bit closer. So what I'm going to do is I'm going to take 13 and I'm going to take 1 away from it. When I take 1 away from 13, I get 12. And then I'm just going to put 4/4, because that's equal to a whole, right? Together, this would be 13, but I wanted to get a denominator of 4, and this was the easiest way to do that. So 12 minus 1/4, and now all we have to do is subtract. These cancel each other out. 4 minus 1 is 3, so we just have 3/4. The shortest fish needs to grow 3/4 inches in order for us to be able to keep them. Number 5. Sea bass can grow to a maximum length of 23 inches. How much more would the longest fish caught need to grow in order to reach the maximum length? So they can grow as long as 23 inches. Well, the biggest fish we caught over here was 13 7/8 inches. And we want to know how much our fish needs to grow in order to meet the maximum. So we have to take that 23, and we're going to take one whole from this, making it 22. And we want eighths, so a whole would be an eighth, 8 eighths. And we're going to subtract 13 7/8 from that. And we have 22 minus 13 is 9. 8 minus 7 is 1/8 inches. Wow, he could have grown a lot more, couldn't he have? Alright, almost done. Almost done, guys. You are doing awesome. Line plots can be a little confusing when we're looking at all those different units of measurement, and then we're looking at different values above that measurement. And so I'm really proud of you guys. I hope you're getting it. I haven't had anybody really contact me with any specific issues regarding the line plots, but we only have one more day of this, and so if you need to get with me for some remedial work, maybe I can explain things, or we can do a couple more practices together, just let me know. Alright, day 7. Number 1. Jack bought 2 umbrellas and 3 hats. Jack bought, for $18. Each umbrella, that's a multiplication word, costs the same amount. Each of the hats, there's another multiplication word, costs the same amount. The price of a hat is $4. What is the cost of one umbrella? So altogether, he spent $18. We know we can probably figure out, let me zoom in, we can probably figure out how much of that 18 was in hats, because we do have the value for the hats. So if he bought 3 hats, and each hat cost $4, we multiply, so he spent a total of $12 on the hats. Can't really see my decimal point. So I'm going to take 18, which is how much we spent, and I'm going to subtract that $12. 8 minus 2 is 6. Those cancel out. So we have $6 here that we could have spent on the umbrellas. We had 2 umbrellas. So I'm just going to divide 2 by $6. 2 goes into 6 3 times. We multiply, subtract, and it all goes in evenly. So each umbrella must have cost $3. Number 2. Anthony wants to buy the same number of hats for 3 of his friends. So the same number of hats for 3 of his friends. He has $57, and each, there's our multiplication word, hat costs $5. What is the largest number of hats that Anthony can buy for each of his friends? So first we need to take that $57 and we need to divide it into groups of $5, because that's how much each hat is going to cost. Well, 5 goes into 50 10 times, 5 goes into 55 11 times, and that's going to get us close enough. 11 times 5 is 55. We subtract. 7 minus 5 is 2. So we have 11 hats. We can't really put that remainder in there because that's not going to be an even amount. They want to know what is the largest number of hats that Anthony can buy for each of his friends, while giving each friend the same number of hats. Understand? Okay. Now if we were going to take that even further, we could find out how much each friend costs by dividing. 3 goes into 11 3 times. 3 times 3 is 9. 11 minus 9 is 2. So each friend is going to get 3 hats. Number 5. Shaquille bought 2 umbrellas and 3 hats and spent between $30 and $50. Each umbrella costs the same amount. Each hat costs the same amount. The price of a hat is $4. What is the least amount Shaquille could have spent on an umbrella? What is the most? So, this is in depth. So she bought 2 umbrellas and 3 hats. The hats cost the same price at $4. So let's find out. She spent, 3 hats times 4. So she spent $12 on the hats. So what was the least amount Shaquille could have spent on an umbrella? So let's subtract our least amount, so because she spent at least $30, and we're going to subtract 12 from that. That becomes 2, 8. So she has $18 left over for the smallest amount. Let's see. Hang on. So if we had 2 umbrellas and we had $18, so the least amount would be 9 divided by 18, which is 2. $9. The most amount, we would have to take 50, our $50, and subtract it from our $12 we spent on our hats. That would be 38, and if we were to divide our 2 umbrellas by 38, 2 goes into 3 once, 9 times. So most amount would be 19. Number 4, which equation is true? Mark all that apply. This requires you to go through and check each equation to make sure both sides are equal. So I'll give you a minute, pause the video, work it out real quick. Alright, we have A, C, I'm doing the mental math, hang on guys, and D. Number 5. Which statement is true about the equation 22 minus 2 equals m minus 7? Pause the video, see if you can't work it out. This is very similar to yesterday's. All you need to do here is you need to find the difference for 22. So we're going to say, what is the difference between 7 and 2? 5. The value of m has to be 5 more than 22 in order to make that equation true. And that completes our day 1, week 4, subtracting line plots. Tomorrow is going to be more of a guided practice, so I will pop on and I will go through and answer, work the problems out really quickly, but we won't go too in depth in it. Just checking to see. Yeah. And then Wednesday we are going to begin understanding angles, which is going to be super fun. If you have some craft stuff at home, like some construction paper and maybe a ruler, that would be really helpful for Wednesday. If not, it's okay. We will make it work. Alright guys, happy Monday. I will see you tomorrow.